Okay. I'm Eric. I work at If This Then That, or IFT. And we're going to be talking about JobScheduler. At IFT, you may know us kind of like as an automation company. A lot of our apps have a lot of syncing architecture to them. And JobScheduler provides an interface that really helps us out with this that we're moving towards. You're going to see why I call it the unavoidable better future in a couple slides. But first, why do we even need an interface like JobScheduler as Android developers? Typically, most people have seen a screen like this where an app just blocks the UI when it has syncing to do. It's a really bad user experience. It's really a poor architecture. This is data that can be updated in the background and rebound to your UI at any later point. Another problem with this is on Android, we have more than just activities as entry points to our apps. We have broadcast receivers and services, and there are plenty of points to sync data in the background. And it's not just for UIs like this. There's more subtle possibilities where we can provide better experiences with things like JobScheduler and GCM Network Manager. For example, you have an email app, and maybe you mark an email as read, or pin an email, or you have a Twitter app and you favorite a tweet, but you're not online. And so you're presented kind of with a choice of, do I just not allow this action in my app now that I'm offline? Do I block the user from doing it? Do I just try to resync my database when my activity comes back in the foreground? But we can be smarter with these things. We can sync when there's data connection available. We can sync when we are on unmetered connections. And that's why we kind of want to build out these binding services and syncing services for our background. So API 1, we have AlarmManager. This was kind of like everybody's first entry into this type of syncing, perhaps. So super simple. We'll get to kind of the downsides, but we have the system service as the Alarm Manager is just a system service. We tell it, we give it a pending intent for maybe our service or our broadcast receiver that we want to launch when we want to do the syncing in the background, and then we can tell the Alarm Manager to set in exact repeating. We can, of course, set just once, not repeating, not periodic. We can set it to exact, kind of for the purposes of this talk around syncing. Typically, we don't really need it to be exact. We're not kind of making an alarm app. And then we provide the approximate time to keep the syncing, but we kind of have the problem of what does our data really look like? We don't really have an abstraction for what happens in that service. All we know is that we're going to wake up our application and start the service, or start the receiver, or start the activity from the pending intent that we provide the Alarm Manager. So the other thing, another downside that maybe is subtle to the beginner programmer or the beginner Android programmer is that your alarms are not reset when you, or are, I guess, cleared when you reboot the device. So again, kind of simple. We need the receive boot permission. It's not a runtime permission or anything, but we add that to our manifest. We throw on a broadcast receiver and grab and then add the intent filter, and then our app is woken up when the device starts, and now we have to reschedule all this. Again, we're kind of seeing where we don't really have any abstraction. What does our data look like? What are the jobs we need to run? We just know that all of our data somewhere needs to be rebound and rescheduled with our Alarm Manager. This doesn't provide any persistence. Again, no abstractions for failures. How do we retry? What's our retry logic? That's all kind of left up to you. Like I said, it's just Alarm Manager is just really an entry point into your app to provide your own syncing architecture. Then the biggest thing, especially for us at If This and That, is we relied very heavily on broadcasts. First of all, new picture and new video broadcasts, you're not going to get them in 7.0. Doesn't matter your target SDK version, you're just not going to get these. If you have a Google Photos app, or you have some kind of photo syncing app, and you were relying on new picture to get woken up and to begin your syncing, you just won't get these broadcasts. This kind of leads into also the purpose behind removing these, in that a lot of apps with Alarm Manager, you may have scheduled your syncing to happen at a time, and then you kind of had the problem where you get woken up, you start your service, and you realize, oh, okay, no user data changed, I don't really need to do anything. And that's kind of the problem of I've just had Android load my app into memory, costing memory and battery, and anything else that I may have done in like my application object or a static initializer. And then I didn't really do anything with it. It's kind of the same thing with broadcast receivers. Android then wakes up, instead of your Alarm Manager with your pending intent, Android will wake up your broadcast receiver in your application when it receives a statically registered implicit broadcast, like these three, for example, and then you realize, well, actually the user didn't turn on the syncing feature in my app. I don't really need to sync any new pictures. And now again, I've loaded my app into memory, I've cost battery. And then also connectivity change. If you target 24 and above, you also will not get the connectivity change. This is kind of a big one for apps that really wanted to do something as soon as they got a network connection, start doing all of their syncing. And then, of course, more. This is kind of a trend. I do suspect in future versions of Android, almost all statically registered implicit broadcast receivers will just be no-opt. You won't get woken up for these. So this presents a problem. Alarm Manager, we still don't really have a good abstraction. We're still loading our app when we don't need to. Broadcast receivers, we're still loading our app when we need to. We can kind of get funny with the broadcast receivers. We can kind of disable components, some hacks around there. But again, these are going away. So the job scheduler solves a lot of these problems. The first being, and then even like provides us again with like some great abstractions. The first great thing is context aware. The job scheduler is not something bundled in your app. It's a system service, like Alarm Manager, on Android, and again, created at boot time, and it knows about other apps' context in the context of the device itself. It knows when there's a network connection, when the device is idle, what the device's charging state is, and even batching jobs among other apps. Again, like we can have a simple app that maybe doesn't even use the network, and it just uses the network for analytics. So traditionally, I have my app, and I just want to send some analytics about how many times people scored in Flappy Bird, and so now I've set an alarm, and I want to sync these analytics, but I don't really care. There's not really a specific time when I need to sync, but I'm going to wake up the device's radio just to sync these analytics. And that's again a huge battery drain. You're going to show up in the battery stats on the device, and you're going to look guilty. Again, not really for any real reason other than you just wanted to do some simple syncing. Another bigger use case is, say you have a device, or say you have an app that syncs your YouTube subscriptions. These are bigger jobs. You don't want to do these big downloads while you're on a metered connection, or maybe while the device is in low power or battery saver mode. And traditionally, you kind of still had to wake up your device. You had to add a bunch of complex options to check. You had to check like in your service when you're syncing. You had to check, okay, am I charging? Am I on the right network connection? It was a lot of complexity that a lot of apps have to maintain. So the basics. We have this abstraction called a JobInfo that the JobScheduler uses. I don't really want to read off like the entire API documentation. Everybody can read that, but I want to hit the highlights. JobInfo Builder provides us with the abstraction. We can have exponential backoff. We can set our backoff policy. We can set a minimum delay for our backoff. We can have the option to persist across reboots. Again, we still need the permission in our manifest. So just remember that. But we can do that. No nonsense with firing up our own broadcast receiver and rescheduling all of these jobs. We can set a maximum delay. So maybe my analytics do need to sync within a 24-hour period. And then, of course, we're also given niceties like charging, network type. We can also set if the device is idle. Android makes a nice interface for telling a job whether to only perform when a device is idle or not, when the user is using it or not. So this is typically like, again, for larger jobs or like Google Play Store installing apps, don't want to slow down your phone or don't want to like take you out of the app when it's installing. Also, in the JobInfo Builder, we have the add trigger content URI. So this is a big one because, as I said, things like new picture and new video are gone. And we still want to get changes for when this happens. We can have a JobInfo, we can have a job get run by setting the trigger content URI on a JobInfo Builder and building our JobInfo from there. This is like so traditionally you would have your own content resolver and you register for these changes, but of course that only works when your app's in the foreground. So you're kind of left without JobScheduler is having your own service and adding your own content resolver scheduling for this, and of course draining battery. Now you can just have that as a trigger for your job. And then the basics, super simple interface really. You get your JobScheduler. You tell it the component name for your service that you want. It's your entry point for Android to wake up your app to begin the job. And then we create our job using all those options that I just showed. And then we schedule a job. Of course, we also have, again, the API provides cancel and also an ability to get your current scheduled jobs. So our sync job service extends a job service. We don't really need to worry about the lifecycle of this type of service. If you do want to override the other methods, make sure you call their super implementations. But what we really care about is onStartJob and onStopJob, and then one more method that we're responsible for calling JobFinish. OnStartJob, the parameter is a jobs parameter, or job parameters. This basically just gives us the bundle, or the persistable bundle actually, that we can set on our JobInfo builder, so that can have primitive extras and arrays of primitives and strings. And then we do our work. This is on the main thread though. So you do need to, again, this is all up to your own implementation for how you want to begin your actual syncing, but don't do large work on this thread. Android holds a wake lock for you. That's guaranteed. So that's a really handy abstraction. And then we need to make sure that we return if there's more work to be done. So almost certainly you're returning true here, but there are cases where maybe somewhere else in your app you had already loaded something into memory, or something else had already done your syncing for you, and you return false and let Android know that you're done. There's no more. You're not starting up another thread to continue your work. Then you do need to call job finished when you actually finish. If you don't, the wake lock won't be released until conditions, the conditions from your JobInfo are not met. Your wake lock won't be released. You'll show up in the battery stats. You'll be shamed by Android. Job finished, you tell it the parameters that you were passed in, and then you tell it if you need to reschedule. So if something happened and your job didn't successfully complete, you just want to let Android know to reschedule. The rescheduling policy, again, set by the JobInfo that you created and scheduled with. So you probably want exponential back off, so linear back off. And then finally, onStopJob. This is called when the parameters that you wanted, like say you only wanted to do this job when you were plugged in, when you were charging, when those are no longer met, Android says, okay, I'm going to release the wake lock. You should clean up anything you want to do. And then it calls onStopJob. Then you need to immediately return whether you need it to be rescheduled or not. Normally true. Of course, register in the manifest. Don't forget. We don't need to export it, but we need to tell. So we don't have to export it. We need to tell Android the permission, and of course, Android has this permission to be able to start your component. So the downside of JobScheduler, especially compared to AlarmManager, is that it's only 21 and above, only on Lollipop. Maybe if you're lucky, maybe like 80% of your users are on 5.0 and above now. It's been out for a couple years, but that's still super unfortunate for the other users. So there's also GCM Network Manager. This also covers a lot of the use cases that JobScheduler hits. And of course, so JobScheduler has the advantage of knowing about the context of other apps and being able to batch services and batch your syncing because it knows about the other apps in the platform. It is in the platform. GCM Network Manager, of course, is in Google Play Services, so it also knows about the other apps and the state of the device. The downside, of course, is that it's only for devices with Google Play Services, but of course extends down to, I suppose, API 7, or however far down Google Play Services still supports. This is a fairly similar API But instead of a job, we have a task. And instead of telling a job or a task whether it's periodic or if it's a one-time thing, they're actually two separate implementations of the task. Abstract class that's periodic class and one-off task. For the purposes of syncing, I'll mostly go over periodic task. Also, we have a builder interface for us. We set the service, kind of like setting the component name. Instead of an ID, we have a unique tag. It does have to be, and the tag is actually a string rather than an integer, and it has to be a string less than 100 characters. And that's the unique tag, the identifier for your task. You can also set update current, which will override an existing task. It'll pop it out of the queue and then add this task to the queue if it finds the task with the equal tag. Set persisted. Again, want to persist across reboots. You have to have the permission in your manifest. And then the same niceties: network, charging state, but no idle. It doesn't. There's no option for like an idle state that kind of the Android job scheduler gives us. With periodic task, you have to remember to set the period. Google Play services like seconds, so make sure you don't feed in milliseconds there. Then one-off task, basically the same API as the previous slide. The only real difference is instead of set period, we set the execution window. Again, in seconds. The first value there is, it's a window. So is the time from now in seconds that you can be executed, and then the time that it needs to be within. So in this case, that's any time from this task needs to be executed anytime from right now to within 60 seconds. So that's a very quick amount of time. Probably have larger values. Then make sure to register in your manifest. Again, so this is an exported service. We have the intent filter. And then remember to set the permission so that other apps aren't just opening up your service component for whatever reasons. So make sure it has the bind network task service permission. Then what our actual service looks like. So here, again, kind of a similar API now to JobScheduler, but you extend a GCM task service. We don't really need to worry about the rest of the life cycle. These are kind of the two methods we care about. However, major difference, and kind of where you see the major use case difference, you are run on a background thread. It's not up to you, I guess, it's not up to you whether to start a new thread or not. And then it has to be thread safe. This service on-run task can be run from multiple threads due to being run on this background thread. It can be running multiple parallel tasks, and also we're not given the guarantees about wake lock that we're given with JobScheduler. The docs say about 3 minutes. But this is where we see we're really meant for quick network tasks. This is more of kind of the small app with analytics that can be synced at any time use case. And then we return here either a success, a failure, a reschedule. If you return a success, we're popped from the queue. Reschedule, then it reschedules. Pretty obvious. And then key difference. We're not given an on stop. There aren't because the wake lock is just held for 3 minutes. There aren't like parameters that are a kind of a shutdown for us. And if and then even if we're set to persistable, even if we told our task that we want to persist, that only applies to across reboots of the device. It does not apply when your app updates or when Google Play Services updates. So kind of similar now to when we had to reschedule everything in our boot broadcast receiver from our Alarm Manager. We have to reinitialize all of our tasks and reschedule them all when there's an update from Google Play Services or when our app updates. So we need to have our backing data elsewhere. We need to have separate architectures for that. Also, on-run task, I forgot to mention, the task params are just also a way to give you the extras from your bundle that you supplied in the task that you scheduled. So what about Firebase JobDispatcher? So this was something that kind of got everybody excited. I was really excited about it when it was announced. It was provided an interface for drivers. It promised to wrap GCM, and then you could supply your own drivers for JobScheduler or for Alarm Manager, and then you'd have this great way of not relying on Google Play Services to always be there, or not relying on Lollipop to be on the device. The library, it's still referenced a lot in documentation as being the successor to GCM Network Manager, but the repo still isn't on Maven and hasn't been updated since I think June. It hasn't gotten a deprecated label, but I don't suspect it's really going to move forward. So I don't think I'd recommend it over GCM Network Manager right now. All right, so some of the differences here in JobScheduler versus GCM Network Manager. Obviously, limitation of JobScheduler is that it's only on Lollipop and above. Limitation of GCM is only on devices of Google Play Services. There are configuration differences. You kind of saw the API is pretty similar, kind of borrowed, kind of looks like GCM Network Manager borrowed from JobScheduler. You can't configure the back off, for example. It's kind of not really a big deal to most people. I think exponential back off is a pretty sane requirement, I guess, of GCM. It's JobScheduler is persistent. You can tell it to be persistent across device reboots, and it's going to keep retrying even if the device updates Android versions. Your jobs are still going to be there until you tell it not to reschedule them in your service. GCM, though, you still have to have that persisting backing data, because anytime Google Play Services could get updated, and now you have to go fetch all of your data from some file and then reschedule all these tasks. By the way, you should go to talk about QFile tomorrow. Also a great way to kind of deal with this persistence in your own implementation, and then pass back up to GCM Network Manager. So JobScheduler is a lot more configurable. We saw kind of with the wake lock, we were kind of given more control over that, whereas GCM Network Manager is pretty targeted towards very short bursts of network activity. Not really. We could make it work for other tasks besides network, of course, but it's definitely only for very quick tasks. If we had our YouTube subscription syncing app, there really wouldn't be a good place to stick that kind of syncing into our implementation with GCM Network Manager, because we just won't be that wake lock won't be held for us. we would need to create our own service and then hold our own wake lock and drill down on battery without having knowledge of the options, of the triggers that caused us to begin the sync in the first place, like we get an on-stop job from JobScheduler. So JobScheduler is a great abstraction for tasks. We have very simple data. We can persist it. We can put it into our bundle, and we can trigger it only when we need to. We can do. So this eliminates a lot of our use cases around we only want to sync when we get the network broadcast, or we only want to begin syncing when we get our when we're charging. So we don't really need those statically registered implicit broadcasts anymore for those kinds of things. I would say some of the use cases it doesn't address that are still kind of a challenge are we don't have, especially for things like battery and network changes, we don't have a log of what happened there. So this is great for the use case of we need to begin a bunch of syncing when these broadcasts happen, but we don't have a log of when did the battery change, or when did we go on and off Wi-Fi. So certain applications, like we have like if this then that, when users want to log their network activity to a Google Drive spreadsheet, are a lot more tricky, and removing the broadcasts is not the solution yet for us. But as for our syncing architecture, we're totally able to remove a lot of abstractions around syncing our sync adapter and AlarmManager, and that's JobScheduler.